All right. So what does adding to the head look like? Suppose we've got this node over here. We should probably give it a name, some kind of reference to it, right? Because we can't just add this item to the list, right? That won't work. I can't just simply say, hey, the item over here, now is going to point to this thing. Item won't have that pointer. So first thing I've got to do is I've got to create a new node of this that can hold that item. I'm going to call it adding, or we can call it to add. I'm not going to call it temp because it's not exactly temporary. New node that will contain the item. We could call it node, but I feel like that's going to get confusing. I want to remember that this is the one I'm adding. So this over here, I'm going to go ahead and call it adding. So let's go ahead and get that label on. And see, I knew I would need an arrow. So let's go ahead and get this over here. Adding goes over to here, right? So how would this guy become the new head? Let's think about this for a second. So I can't just simply say, hey, the head, this guy, now points to this. I can't do that because something would just happen. And then because we'd get into a bit of trouble. One is that I couldn't connect adding to the rest of the list. And then also we get into a tricky situation with the garbage collector. So the garbage collector is one of those nice benefits in Java, which is that basically once a variable is no longer being used, Java will automatically delete it for you. You'll get rid of it. It will. The garbage collector just kind of goes all Pac-Man on it. The way it tells whether you can delete something is the number of references that are there, right? Right now, this node doesn't have any references to it, so it would get garbage collected, which would make this guy have no references to it, which would make he would get garbage collected. So the only thing keeping this entire list intact is this arrow right over here, the head. So let's go ahead and game plan this then. The first thing we want to do then is connect adding to head like that, right? So now the list looks like this. And then the next thing we can do, as soon as that's done, then we can say, hey, this node is now the head. And then we can just kind of just move this over here and put it into place, right? And then the adding will go away after the end of this, or the adding label will go away after we are done with the add loop. So let's go ahead and see how that works in practice. Okay, so let's go ahead and move these guys over. Okay, so we've got adding. So this line creates this over here. If index is equal to 0, which is what we're working with here, then the first thing we want to do is connect the new node that we are adding. So we simply say adding.next. We want to store the memory location of head. So we take the memory location of head and store it in adding.next, which ends up drawing like this. Right? Addings.next now has the memory location of head. Right? We'll come after adding. Head will. Okay. Now we will say head is equal to adding. We're going to take the memory location that's stored in adding and store it now in head. So we're going to take that label, and now head is going to point over here. And now we've noticed how everything has successfully shifted their indices automatically. So adding, insert to there, and so on and so forth. So now 0 is now 1, 1 is now 2, 2 is now 3, right? Because this guy will now be index 0. That's fantastic. So adding to the head is a fairly straightforward thing. We do adding.next is equal to head. We store the memory location of head in this thing's next pointer, and then say head is equal to adding. Now, interesting to note, what if it's null? What if we don't have all this going on here? What if this is the situation? What if this is our situation? It still works, right? Head is equal to null, right? So adding.next is equal to null. So this will point to nothing, which is perfectly fine because that's exactly what head is pointing to. And then we say head is equal to adding, so we store the memory location of adding inside of head. So we're going to take this this guy, and now he points to here, right? So it works with the first item as well, which is brilliant. This is one of the reasons why I consider this to be a great way for this, because you don't really have to think about those null pointer exceptions too much. So for our next video, we are going to knock out the last one, which will actually involve us writing a separate method.